Good morning, geometry students. Today we are going to be talking about section 5.5 from our textbook. We cover some information about triangles. So the first thing we're going to talk about is the relationship between the lengths of the sides and the sizes of the angles. So we're going to go ahead and list the sides and angles in order from smallest to largest. So it's easy to do the sides because they have numbered lengths on them. So we can see that AC is the smallest side, then AB, then BC. All right, so the angles don't have numbers on them, but here's what we will know, and that is this is the smallest side, right? Shortest side. It is going to be across from the smallest angle. All right, so we know angle B is going to be the smallest angle. I mean, it looks the smallest, it is the smallest. Okay, and when we look at the longest side, right, 12 was longest, go across from the longest side, and you should be at the largest angle. So we know that angle A is the largest angle. And that makes angle C across from 8 being the middle angle. All right, so this is a relationship, right? This is the largest of both sides and angles. And these are the smallest of both the sides and the angles. Always been true since the beginning of triangles. Just never really thought about it. Okay. The next piece of information about triangles is called the triangle inequality, and this deals strictly with side lengths on triangles. So before we write it up, I'm going to give you an example or a demonstration. So here are 3 little sticks. Can I make a triangle out of these 3 sticks? Okay. So if I tried to attach them at the ends like that, you could see very clearly that there's a problem. You know, this side is just too long for the lengths of those little sticks right there. So I'm going to go ahead and give some little lengths right here. I know these look about the same. I'm doing rough approximations here. We'll say if that one is 7 inches, this one is 2, and this one is 3, right? They're just not long enough. In fact, this is what we're going to look at. If I collapse them here, you can see that they're not, these two together, the 2 and the 3 are not even as long as the third side of the triangle. So we scratch our head and we go, well, that's a problem. All right, so I'm going to take one of those little sticks away there. Okay, so I took away the 3-inch stick, and I kind of left the 2-inch stick there, and I replaced it with this one. We'll say that one is 5 inches long. So these line up exactly, right? Comparing to the longest side, the other 2 sides exactly, when you add them up, equal the third side. And that also presents a problem, because when you try to make a triangle there, you have the same problem. These sides together are not long enough. Okay, so a comparison that we can make is when you add up the 2 shortest sides, they are not longer than the third side, they equal the third side. All right, so let's take one more stick away, and we'll bring this guy out. And this guy is 4 inches. And now we actually can make a triangle, right? If I collapsed these down end for end, there would be an overlap here, right? This tells us that these 2 shortest sides are longer. When you add them up, right, they're longer than the third side, and that is basically what the triangle inequality says. It says you take any 2 sides of a triangle, add them together, they have to be longer than the third side. Okay. So back to here, let's go ahead and just draw a triangle. I'm going to kind of just make it look like the one up above. A, B, C. Okay, so what I showed you is that it was obvious as to which was the longest side, but the triangle inequality kind of makes it more generic. It says the addition of any two sides of a triangle must be greater than the length of the third side. Okay, so to me it looks like AB and AC are the two shortest sides. And so you add them together, they have to be greater than BC. You'll see with some of the problems we work, it's going to be hard to maybe tell what is the shortest side, or the longest side, I should say. So I'm going to go ahead and write this three different ways, right? AC plus BC, right? These two sides have to be greater than AB. AC plus BC has to be greater than AB. All right, and then the third one would be these two sides, right? AB and BC together. AB plus BC has to be greater than AC. So that is the full triangle inequality. Pick any two sides on the triangle, add them together, has to be greater than the third side. Okay, so down here, we'll start working some examples. These are the easy examples because you can clearly see what is the longest side, right? The longest side is 10. So we just have to guarantee that the two smallest sides, when you add them together, have to be greater than the longest side. So we're going to just guarantee 7 plus 8 is greater than 10. I didn't read the question. All right, so we're going to state if the three numbers could be the lengths of the sides of a triangle. So we're going to check this with the triangle inequality. So I'm a big fan of just doing it once, and I'm only going to check the two shortest sides. But if we use the full triangle inequality, then it would say this: hey, let's take the other two sides, right? 10 and 7. You add them together, they have to be greater than 8, which, you know, since we know 10 is the longest side, it's kind of silly to do this, because no matter what you put there, the 10 is already bigger than 8. So, of course, 10 plus 7 is going to be bigger than 8. All right, and then you could do it even a third time, triangle inequality. So if you took the 10 plus the 8, that would have to be greater than 7, which the 10 already is greater than 7. So adding 8 to it seems kind of silly, but so I always say check the two shortest sides and see if they're longer than the third side. All right, anyway, this one is a yes. It totally fulfills the triangle inequality. 9, 1, and 10. So take the two shortest sides, and we're just going to see if they are greater than 10. Hey, 10 is actually not greater than 10. That will not make a triangle. Those three segments will not make a triangle. So this one is a no. Okay. And here, again, when you have just three numbers, that's why these are level 1. You totally know what the longest side is, right? You're just checking to make sure that the other two sides, when you add them up, are going to be greater than the third side. And they are. So this one is a yes. Okay, level 2 questions. Harder. So the level 2 questions say two sides of a triangle are listed. Find the range of values that the third side could be. So the dilemma is we don't really know if this x, it could be the largest side, but maybe it's not, in which case 11 would be the largest side. So we have to do two problems for each one of these. Okay, so we're gonna think of two scenarios. Let's just say if 11, let me scoot it over. I think I'm going to go off the paper. If 11 is longest, right? That would make these two the shortest sides. So we would set up our equation that says, hey, the two shortest sides added together have to be greater than 11. Okay, so the other scenario is, what if 11 isn't the longest side? We know 8's never going to be the longest side, so we don't have to worry about that scenario. But what if x is the longest side? If x is the longest side. Okay, then our equation is going to look like this. 8 plus 11 is going to be, has to be added together greater than whatever x is. So 19 is greater than x. This is written backwards. We're going to turn the whole thing around and say x is less than 19. So we have two answers right here, but notice that the symbols are going in opposite directions, right? This says, hey, x has to be greater than 3, but x also has to be less than 19. So we'll go ahead and shade our solution on a number line. This is a good review of Algebra 1 skills. So when you do it on a number line, you always put where 0 is for reference, and then put that number 3, and put this number 19. Okay, and because we're not doing any equal to's, only strictly less thans or greater thans, you put open circles on those numbers. And this says x is greater than 3, so we're going to shade all of the values greater than 3. And at the same time, x also has to be less than 19, so we're going to shade everything less than 19. So x can be any number in this range, right? And it will create a legitimate triangle with those other two side lengths. Here's how you write it in the sandwich form. X can be less than 19 and at the same time greater than 3. And I know that's a less than symbol, but this half of it is written backwards, right? You've got the x on the right-hand side. So it really does mean that x is greater than 3. Okay, we'll do it one more time. So we're going to think about the scenarios. This could be the longest side. 6 will never be the longest side. So we'll just think about if 10 is the longest. Then we know that these two numbers, right, these other two sides, x plus 6, has to be greater than 10. So x has to be greater than 4. But the other scenario is that maybe x is the longest side. If x is longest. All right, so that would mean that when you add 10 and 6 together, they would have to be greater than the x side. 16 greater than x. It's backwards. I'm going to turn the whole thing around. So I move the x over, flip the symbol, and move the 16 over. So these are our two ranges, greater than 4 and at the same time less than 16. Open circles, greater than 4 shades to the right, less than 16 shades downwards. Okay, so when I write it in the sandwich format, the shading x is less than 16 and at the same time greater than 4. Okay, so I'll go ahead and work this next one, and I'd like for you to maybe pause the video and you work it too. See if in the end you come up with the same answer I do. Pause. Alrighty, should be any x value greater than 4 and less than 70. Okay, two level 3 equations or inequalities. These are a little bit harder. So the first one here is the easier of the two because at least, you know, you have an actual side length for two of the sides. So we could still play that game, right? That maybe 7 is the longest side. I know it's drawn like it is, but we can't guarantee just because that side looks shorter that it actually is when there's an X there. So we're gonna set it up as if 7 is the longest side. So we're gonna put 7 over on the right-hand side, right? If that's longest, these two added together have to be less than, or greater, sorry, greater than it. So 5 plus 2x minus 2 has to be greater than 7. All right, let's see. 2x, let's see, 5 minus 2 is 3. X has to be greater than 2. That's half of our answer, but the other scenario is, what if this side is the longest, right? So we're going to go ahead and put 2x minus 2 on that right-hand side. And we would have to know that 5 plus 7 has to be greater than 2x minus 2. Written backwards, we're going to go ahead and turn it around. X has to be less than 7. Okay, so our window for X values is greater than 2, less than 7. Let's see, so there's the less than 7 part, greater than 2. Okay, I didn't make the number line. Go ahead and I should do the number line first, but there's 0, 2, 7. Open circles, these all have open circles on them. All right, last example is for sure the most lengthy because with all of the sides having little expressions on them, we really can't tell which is the longest side. We shouldn't assume by looking that, you know, the expression that looks like it's written on the longest side is the longest side. So we have to do 3 inequalities. All right, so let's set them all up, right? So our first inequality would be to say that these two sides added together have to be greater than the third side. So that is 6x minus 11 plus 3x minus 1 greater than 2x plus 3. Okay. Now I'm going to space it and give myself some room to work. The other second one that I could do would be to say maybe this side and this side together, right? 6x minus 11 plus 2x plus 3 has to be greater than 3x minus 1. All right, and the third inequality is these two sides added together. 3x minus 1 plus 2x plus 3 has to be greater than 6x minus 11. So we have 3 inequalities to solve. And in the end, we'll talk about how you know which is the proper range because we really only want 2 answers for all of these, but we're going to get 3 on this one. All right, I will pause. Oh, I won't pause. We'll just go ahead and do it. Let's see, 6x plus 3x, so that's 9x minus 12, 2x plus 3. Okay, so this is a case where I usually am a fan of improper fractions as answers, but we are going to need to compare our numbers in the end, because where they fall on the number line actually helps us get the right final answer. So I'm going to turn this into a mixed fraction. 2 1/7. So that's one of my answers. Okay, we'll move on to the next one. 6, 7, 8x minus 8, x minus 1. Uh, 1 2/7 for that one. All right, and last one. 3, 4, 5. 5x plus 2. This one's backwards, so we'll go ahead and turn it around. Okay, so here's what we're looking at. 3 different answers. Notice in the first 2, these are both lower bounding numbers because we're saying that x has to be greater than those 2. This is definitely the upper bound. So if we go to the number line, we'll go ahead and plot 13, 0. Now I'll plot them both, right? 1 2/7 would be, at least, you don't really know exactly because I'm not ticking out, exact little increments here, but I know that 1 2/7 would fall to the left of 2 1/7 because it's a smaller number. All right, so what I want to do when I pick my final answer is pick the smallest region of x values, which would be the less than 13 combined with the greater than 2 1/7. This is a smaller region. If I picked a number in here, for example, to use up here, it wouldn't fulfill the triangle inequality. This guarantees triangle inequality will always work for this triangle up here. So my final answer is less than 13, greater than 2 1/7. All right.